Hello dear students, how are you? And welcome back again to our online lessons. Yesterday we have started our new lesson about nuclear reaction, and today we're going to discuss about one kind of nuclear reaction called radioactive decay. So what do we mean by radioactive decay? It's a nuclear reaction in which an unstable nucleus can give off energy and sometimes particles. The particles and energy given off are called nuclear radiation. So the unstable nuclei continue to decay until they form stable nuclei. And here we have three different kinds of radioactive decay: alpha decay, beta decay, and gamma decay, and we're gonna inshallah discuss about them all individually. So let us start with the first type of the radioactive decay, which is the alpha decay. Alpha decay is the release of an alpha particle and energy from a radioactive nucleus. An alpha particle consists of two protons and two neutrons. As we can see here in the following diagram, we have a kind of element called radium, and the nucleus of this element is unstable. So to become stable, it will release certain kind of particles. In this case, it will release alpha particle. And as you can see here, alpha particle is made up of two neutrons and two protons. So this is the structure of alpha particle. So after this element release the alpha particle, what do you expect to happen, guys? Yes, exactly. You remember what we discussed yesterday? We said that whenever there is a decrease in the number of protons in certain nucleus, the atom will change into a completely new atom. So this element, radium, will convert into a totally different element called radon. So alpha decay produces atoms of different element because it reduces the number of protons in the nucleus. Number two, beta decay. Beta decay is the release of a beta particle and energy. There are two types of beta particles: positrons and electrons. Both particles, positrons and electrons, have a mass of almost zero. Positrons have a charge of +1, while electrons have a charge of -1, and this diagram represents for us the process of the beta decay. Here we have an element, this element called carbon, and we can see that after the release of the beta particle, the carbon converts into a new atom or a new element called nitrogen. Again, why? Because the number of protons decreased. The third type is the gamma decay. Gamma rays are released during gamma decay. What are gamma rays? Gamma rays are high energy radiation and have no mass and no charge. Gamma decay alone doesn't change the number of particles in the nucleus, therefore it doesn't form a different element or isotope as we saw in the alpha decay and in the beta decay. So now let us discuss how does radioactive decay affect matter. Here we will discuss about the advantages and the disadvantages of radioactive decay. Let us start with the harmful effect of the radioactive decay. So although alpha particles do not penetrate deeply, they can damage living cells by breaking apart chemical bonds when they hit substances. For the beta particles can also break molecular bonds in cells and cause illness. What about gamma rays, guys? Actually, gamma rays have the greatest penetrating power. They can remove electrons from atoms, damaging cells and weakening metals. Large doses can lead to radiation sickness and even cancer. How is radioactive decay used? Now we need to discuss some of the useful application of the radioactive decay. Number one, many smoke detectors contain a small amount of radioactive compound or substance called americium. The americium, as we can see here in this photo, emits alpha particles that are used to detect smoke. Number two, gamma rays are used to kill bacteria on bandages. As we say, gamma rays has a great penetrating powers. That's why we use gamma rays to kill bacteria and to kill microbes. Number three, radioactive decay is used to test the thickness of metal sheets and to find leaks in pipes. What else do we have, guys? Number four, scientists use radioactive isotopes to determine the age of artifacts, remains, fossils, and rocks. So radioactive decay actually used a lot in the geological field in order to age the rocks and the geologic events. We have another application, guys, for radioactive decay in the medical field. Radioactive tracers are often used to produce images of human body parts, as we can see here in this photo. This is what we call the nuclear imaging for the human body. What else do we have? Radioactive material inserted into a tumor can kill the cancer cells that make up the tumor, so we can use the radioactive material or the radioactive decay as a technique for the treatment of cancers. So here we have this question, guys, and let us try to answer it together. Use this model to answer the following question. What decay process is shown and explained? So here we have an element, this element called radon. Radon will emit particles here and it will convert into a different element called polonium. So what is the particles here, guys? Do you remember? Yes, this is alpha particle that is made up of 2 protons and 2 neutrons. After the radon emits this alpha particle, it will convert, as we said, into a new atom or a new element called polonium. So the decay process shown in this diagram represent the alpha decay. So that's all for today. Thank you, guys, and see you inshallah tomorrow.